Alright. I'm Ryan Hall. I'm from Rhinebeck, New York, and I attend Alfred State for the Mechanical Engineering program.
I am Jacob Patanella. I'm from Rochester, New York. I also attend Alfred State in the Mechanical Engineering Technology program.
I'm Brad Marshall. I am from Elbridge, New York, it's in Syracuse, and I am also part of the Mechanical Engineering program here at Alfred State.
And our project is going to be a hydraulic plastic film shredder, and with the help of Dr. Lawrence as our advisor.
Our motivation for this work is all three of us have had an interest in hydraulics since we came to school. I know me and Ryan, myself, have had experience on tractors and such, as well as Brad. This year, in our 7th semester, we are taking a fluid power system design class with our advisor, Professor Lawrence. And we've learned quite a bit through that class, and recently he came to us with a design, not actually a design, but he came to us with a prompt that he wanted us to make a plastic shredder, and he wanted 2 groups, one for rigid plastics and one for film plastics. We both are equally challenging, and while they're similar designs, there are a few differences that will be talked about later. So we chose the plastic film shredder, and we thought that we would work well together as we've been friends since freshman year, and we all have a passion to solve this goal together and to graduate with this senior project. And the problem we're going to be solving deals with plastics and plastic pollution, which everyone knows is a major problem this day. The outline of our project is to create a product with significant contributions that solves a current issue. So basically what that means is we can't just take something that already exists and just make one. While it sounds like what we're doing, to the best of our ability, we're going to improve upon the plastic shredder. Well, some of our ideas right now are improve upon cleaner cuts, better efficiency, make the machine more compact, more usable, and that will also be talked about later in these slides. So that also goes along with originality, and we've learned a lot through our years at college here at Alfred State. While some of it will not apply to this senior project, we will have to show off the knowledge that we learned. So having an entire project process from design, from approval to design to fabrication to testing to final report, definitely will be the closest to industry that we can get before we graduate. Speaking of industry, this also has to have some sort of impact with the industry, and this isn't quite industry specific as everybody uses plastics, and while it's not an industry, the issue of plastic pollution can be decreased through the plastic shredder. And also, we need to add a couple principles to the plastic shredder that are visual and non-visual, so that if this were ever patented or in a real world situation, someone couldn't just look at what ours is and immediately tell why it's better and copy it. So the current real issue is that our resources are being used or burnt faster than we can replace them, and there has been a huge increase in alternatives, but unfortunately they're far from ready to be used extensively and to completely replace those resources. Because of this, we all know and have been taught since an early age with plastic pollution is to reduce, reuse, recycle, and reclaim. And while this is a great beginning, it also does not eliminate the use of plastics, as it is near impossible to reclaim everything that we use since there are so many of us. For example, millions of plastic bags are used daily and then thrown away. And we are increasingly throwing millions of pounds of plastics that just end up in the landfills or oceans, which creates a domino effect for a ton of other issues that will come back. Plastics share the same energy per unit as gas, diesel, or coal. And using this information, we thought, how can we benefit from this information? So our real solution, what we came up with, knowing the energy that plastic possesses, is that we could use this as usable fuel. Now, one thing about plastic is that if it's burned at a specific temperature, it is safe, environmentally safe, while if it is not environmentally safe. But this takes some engineering. And the plastic film, specifically for our plastic shredder, it needs to be compacted into small plastic pellets, which will then be put into our advisor, Dr. Lawrence's Plastifuel machine, which he has designed and fabricated himself and has been approved upon, and that is in our hydraulic lab. So this machine will adapt to that right into the hopper, where it will create plastic pellets to be used as usable fuel. So the great thing about plastic bags, they're flexible film-like materials, so they're easy to form into pellets. We haven't tried any testing, but we have done some multiple research through videos and other websites. So they should be easy to shred more than rigid plastics. But while this is true, it will also need to process a lot of weight quickly to make those pellets versus, you know, one rigid plastic bottle could possibly make a bunch of pellets. One plastic bag might not even be able to make a pellet in itself. So that's one issue that we will resolve. The plastics also must be sorted. There are, I believe, 8 different plastics, and some of them cannot be burned. But plastic films, fortunately enough, most plastic bags are made of the same material, which can be compacted into small pellets, which can be burned. And the great thing about burning this usable pellets that we make through the Plastifuel machine is that it can offset the cost of heating for small or large companies or in the home. And that's one thing we're really going to focus on, is making a compact plastic film shredder that is going to have plenty of variations for anybody who is using plastic every day, or anyone that is environmentally sound and just has a few pieces of plastic that they can use to offset the cost of heating. And while this will not offset the cost of heating completely, it is better than throwing these plastic bags into the landfill or having them end up in the oceans.
All right, some contributions to the project will be to have this device be less weight and heavy duty as possible. With this device, it's also possible to eliminate the compression device that's feeding the hopper of Dr. Lawrence's Plastifuel machine. Obviously, this machine will be hydraulically powered with a high-speed, low-torque device. And to make this as efficient as possible, it'll be variable speed as well, making so that we can have the optimal speed for the amount of plastic we want shredded at a certain time. Again, with the smaller tolerances, we can shred the film plastic a lot easier, making it possible to compact the plastic into pellets. Okay, so for our idea, we looked at a plastic shredder using a 40 horsepower electric motor, which is a belt, has a bed knife on it, which this obviously would be too big for our application, but we took some design concepts as a starting point to look after. Our machine is going to be fed with a hydraulic pump with a 2.7 gallon per minute flow rate with an 800 psi, and we're looking to make this a single compact unit that's put onto Dr. Lawrence's Plastifuel machine. And our goal for this project is to have the plastic shred 20 pounds per minute. Design concepts, we can look at the efficiency of the hydraulic plastic shredder, as well as a high speed and low torque device. The finished product must have pieces shredded into a 1 by 1 inch dimension for it to be compacted into usable pellets. Using our previous knowledge in mechanical system design class, as well as our knowledge of hydraulic power, we are going to be able to create and complete 3D model rendering, as well as all calculations necessary to complete the project. As well as you create working industrial drawings to be able to fabricate this device. And some concepts and preliminary ideas are as shown in a 3D isometric view. You can see the rollers being integrated together in order to get that small 1 by 1 dimension that is used to compact into hard plastic pellets. And the images to the right, you can see that they are, people have created these for larger chunks of plastic or metal, but we plan to shrink this design down to roughly 1.5 feet by 1 foot. So it'll take the plastic bags easier and be more suitable for the classroom setting.
So we will be completing this project over the course of 15 weeks. The process in which we're going to go through with that is probably going to be starting with the calculations for operation, as well as, you know, the parts that we're going to need and stuff. Probably determine like bearing calculations and weld calculations, all that kind of stuff. Once we've completed the calculations and we know exactly how things are going to be working out, then we're going to be working on the actual 3D model of it to work off of for fabrication. A lot of the parts are probably going to be bought from some manufacturer, but if there are any parts that we need to fabricate ourselves that don't come standard, then we have the machine tools for that. We have all got some experience involving that kind of stuff. In a manufacturing processes class, we used engine lathes as well as milling machines to produce things. And in our mechanical design classes, we went through, did the calculations for whole systems, followed up with that by doing 3D models of those systems, and then finally finishing it with professional drawings and stuff to be submitted for projects and requirements. Probably going to have to redesign a couple of times. I imagine that our first idea won't be working out as well as we hope it was. But that's how it goes with engineering, trial and error. We're going to stay in contact with Dr. Lawrence throughout the entire project. In order anything changes between either our side of the project and his side. If anything changes as far as, you know, the kind of funding that we might get, we'll have to adapt to that, as well as any problems that we come across. We'll have to report to him, you know, tell him that we're falling behind, or, you know, try and come up with a solution to adapt to such problems. Just basic communication. And then after we've done the calculations, run the numbers, started to order things and put it together, hopefully it'll all work in the first shot. Who knows what's going to happen with it, but if it doesn't work, then we'll have to go back and revise and change up the numbers and see what will work. Standard, you know, engineering procedure. Now, this shredder is going to be used in a bunch of different situations. Large companies that either produce or take in plastic bags and other light film-like plastics could use this on an industrial scale. It could also be used in like smaller companies like grocery stores, supermarkets and stuff, with all the protective stuff. Some standard operating procedure, of course. We could also make an ergonomic style that can be used at home, you know, kind of like any other appliance you'd use, like a washing machine or a refrigerator, so that, you know, instead of having to run out to like a plastic return, you can just shred it there and then, you know, have it bagged up and compacted, or maybe even use it for fuel yourself, you know, right there. So this is our Gantt chart. This shows everything that we're supposed to do and a timeline for it, gives all the constraints for time frames and stuff. We should be able to follow this pretty easily, I think. Everything should be done within the 15 weeks, so 176 days. And if we fall behind on something, then we'll just have to adjust this as we go. I do believe that we can work with it though, as it is. As previously stated, the cost of the materials will be helped out by any potential SUNY grant that we get. We'll be hunting for discounts and stuff through marketing stores like Grainger or State Line Supplies. Any extra costs that we can't cover from those two places, or from a grant, or from other stores, we'll just cover by, you know, Ryan, Jake, and I. Anything fabrication, we'll be doing it together, making sure that everything's done right. So it's going to be a lot of communication, as well as working together, being there as we're getting the stuff done. Yeah, that's how it's going to have to go. It's going to have to be a lot of communication and a lot of just staying on the same page for all this is going to be the real trick. We might try to get a head start on this over a little bit before the next semester starts. Our 8th and final semester begins. Depends on everybody's work schedules and stuff, you know, what comes up over that break. We should be able to at least be prepared to have a basic idea for what we need to make here.